In this section, we're going to look at something called absolute convergence. And we say a series is absolutely convergent if the sum of the absolute values is a convergent series. In the case where the terms of the series are already positive, then the sum of the absolute values is the series itself. There's no change. So absolute convergence is exactly the same as convergence. Let's check the following series for absolute convergence. Take the series, the alternating series, the sum from 1 to infinity of minus 1 to the n plus 1 over n cubed. The question is it absolutely convergent? Well, to check that, I look at the sum of the absolute values of the terms of this series, and disregarding the plus and minus ones, I get that the sum of the absolute values is the sum of 1 over n cubed. And the question is this series convergent? And I know that the sum of 1 over n cubed is a p-series with p bigger than 1, so it converges. So therefore, the original series, the sum of minus 1 to the n plus 1 over n cubed, is absolutely convergent. Now for the series on the right, we know this is the alternating harmonic series, the sum of minus 1 to the n over n, and the question here is this absolutely convergent? Does the sum of the absolute values of the terms of this series converge? And the sum of the absolute values of the terms of this series is the sum of 1 over n, and this is the harmonic series. It's a p-series with p equals 1, so I know it diverges, it doesn't converge. So the answer to my original question is that the alternating series, the sum of minus 1 to the n over n, is not absolutely convergent. Now, a series might not be absolutely convergent, but it might still be convergent, and we have a name for that that's called conditional convergence. So a series, the sum of an, is called conditionally convergent if the series is convergent, but the sum of its absolute values is not. And let's check to see which of the above examples are conditionally convergent. Well, since the series, the sum of minus 1 to the n plus 1 over n cubed, is absolutely convergent, then it doesn't qualify to be conditionally convergent, because part of the definition of being conditionally convergent is that it's not absolutely convergent. So that series is not conditionally convergent, but it is absolutely convergent. On the other hand, the alternating harmonic series is convergent. We know that using the alternating series test, but the sum of the absolute values is not convergent. So our alternating harmonic series is conditionally convergent. The sum from 1 to infinity of minus 1 to the n over n is a conditionally convergent series. Well, here's a theorem, and a very important theorem. If a series is absolutely convergent, then it's convergent. So if a series has positive and negative terms, and if you look at the sum of the absolute values and you discover that that's convergent, you can conclude that the series is convergent. Let's use this to test the following series for convergence. The sum from 1 to infinity of minus 1 to the n plus 1 over n cubed, we saw already that that's absolutely convergent. The sum of the absolute values is convergent, so we can conclude immediately that this series is convergent. Of course, we could conclude that using the alternating series test, and this is an alternative way of doing it. Let's consider the series on the right. This isn't really an alternating series, but it's quite possible that some of the terms are negative. It's the sum of sine of n over n to the 4. Now, sine of n could have positive or negative values, and this series may have negative terms. Well, let's check the series for absolute convergence. Looking at the sum of the absolute values of the terms of the series, we're going to use the comparison test. So I suspect this series converges, and I'd like to compare it to something that I know is convergent. And I know that the absolute value of sine n over n to the 4 is bigger than or equal to 0, but it's also less than or equal to 1 over n to the 4. So I'm going to compare this series to the sum of 1 over n to the 4, which is a p-series with p equals 4, and I know it converges. Since the absolute value of sine n over n to the 4 is less than or equal to 1 over n to the 4, I can conclude that the sum of the absolute values of sine n over n to the 4 is a convergent series by comparison with this p-series. And now my theorem says that the original series converges also, that the series with the terms which might possibly be negative is also convergent. So the series, the sum from 1 to infinity of sine n over n to the 4 is convergent because it's absolutely convergent.